the do now problem. Just asking simple true false. All right, determine whether each claim given below is either true or false. All right, so some of them seem silly, like unreasonably unnecessary, but they're there for a reason. Right now, I am in math class and English class. True or false? False. All right, not going to be at two places at the same time. Two different places at the same time. Right now, I am in math class or English class.
True.
True. You're in one or the other. It just so happens you are in one of them, so it makes the sentence true. Now, if you're sitting in, I don't know, like I was thinking like Mr. Smith's history class, then, or like Mr. Plutzker's, what is it, earth science? What does he do? It's earth science, yeah. If you're sitting in one of those classes, then it would not be a true statement. But because you're either in math or English, in this case math, it satisfies that statement. All right, so very important. We're going to actually learn from these two sentences. And what we're going to do is create what's called a truth table. And we'll just do it off on the side, nothing too crazy. All right. So we're going to create two columns, one with P and one with Q. P and Q just represent two different portions of a statement. All right. So what I want to do is determine the truth value of each of them and then how those truth values relate to one another. So P and Q. All right. So that's the and symbol. Upside down V is and. All right. So the possibilities are that maybe both parts of the sentence are true. All right, true and true would give you a true sentence. All right. So, and that would be the case where somehow you could be in math class and English class at the same time. All right, I suppose that's possible. Like you can be in English class and history class at the same time, right? Sometimes they open the door. All right, so that's possible. Probably not math and English, maybe math and science, but consider a situation where we're working on a science application of a math problem. You can kind of make the case that we're kind of in math class and science class at the same time. All right. Now, the other possibility is you're in math class, but not in English class, and we've already established that that's false. It could be the other way around. If you're sitting in your English class, then you're not in your math class. False, false, false. False, true, false, I mean. The last possibility is that you're in neither of those cases. Like I was saying before, you're in Mr. Plutzker's earth science class, or Mr. Shippey's. Shippey. All right. So if that's the case, then what we gain from this is the idea that the only way an and statement can be true is if both parts are true. All right, that's the only way that you're going to get a true sentence. All right. The and part is known as a logical connective. All right. Regardless, it's the idea that you're looking at two distinct, verifiable sentences put together to make a bigger sentence, a compound sentence. All right. And if the only way it's going to be true is if both parts are true. All right. Now the other case would be the or situation. All right. So the or symbol is a V for some reason. And so we could have P, Q, and then P or Q. All right. So we looked at the situation here where I said I'm in math class or in English class. Well, we looked at one possible case as I'm in the math but not the English. So that would be true or false. But let's actually just use the same progression we did for and. And that would be true, 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 false, false, true, and false, false. All right. So I'm in math class or English class. All right. Well, we knew that if either part of that sentence was true, the whole thing would be true. If the statement said, if I'm in math class or English class, and again, I'm sitting in Shippy's earth science class, then I'm in neither of those, so it would be false. The weird one is the case where both parts are true. That's actually going to be true also. But that's kind of strange because in this particular case, you think, well, there's no way I could be in both at the same time. But that was the example I was using before. You know, what if you're dealing with a math science application kind of question, right? You can make a case for it. But also, I mean, I could go with a simpler example. Like I'm wearing a red shirt or black shoes. Now, if I walk in wearing both a red shirt and black shoes, your instincts are to say that that's false because like it feels like it's a one or the other. But the weird thing about the or sentence or the or connective in probability mathematics is that it allows for both parts to be true. All right. So that's the one little adjustment that you have to make based on what your normal perception is and what is happening in math class. And sometimes that's the case. But if you have these ideas in mind, then you're in good shape because all these other questions are actually a whole lot easier. All right. So I'm going to circle the false, false, false because that's the only instance in which a or sentence is actually false. So all I have to do is take a look at the sentence that I'm given and look at each part and make a determination of the truth value of it. So 3 plus 5 is 8, true? I have an and. Now, what's 7 minus 1?
Oh, 6.
6. Is 5 less than that? Yes, so true and true is going to be true. Is 10 plus 12 not equal, 10 plus 2 not equal to 12? No, so that's a false sentence. And the other one's true, but it doesn't matter at this point. The whole thing's going to be false. Because in an and sentence, if one part is false, the whole thing's false. All right. 5 plus 4 is 9. Is 3 less than 9?
Yes.
Exactamundo. Now it doesn't matter what the other part is, because the whole thing's going to be true. Because in an or sentence, the only way it's going to be false is if both parts are false. All right, but just for giggles, I'll figure it out. 6 plus 4 is 10. That's not equal to 9, so it's a false sentence. All right. 16 minus 20, what's that? Negative 4, that's not bigger than 1, so false. Or, now what's 5.5 plus 4? 0.5. 10 even. So that's not equal to 11. So we're looking at false. So the whole shebang is false because each part is false. All right. So he took a real life situation, well, real life, as real life as it can get, I guess, and then used that to learn about the mathematics, and then use that to draw some general rules, which allowed us to advance the plot a little bit. All right. Examples of declarative compound sentences. When the two declarations in a sentence above were separated by and, what had to be true in order to make the sentence true, both parts? All right. When the two declarations in the sentence above were separated by or, what had to be true in order to make the sentence true, either part? All right. So the next little bit is a little bit more of an exploration, but I'll take you through at least one or two of them, and then I'll set you free, and then we'll do an exit ticket at the end, an easy one. It'll be a group ticket. Ah, he's got a plan. All right. So answer the following questions. Can you think of a number that is less than 3 and also greater than negative 1? 1? Okay. Can you think of another one? 2. Yeah, using the number line graph the solutions where x is greater than 3 and less than negative 1. So we have the 1, we have the 2, but we want to be less than 3, so open circle on the 3. And we also want to be greater than a negative 1, so open circle on the 1. All right. So we're talking about all the values that are in between the two. All right. So just off on the side, or maybe at the bottom, I'm just going to show you a different way of doing it. If this way made sense, then you're fine. You don't have to worry about this. But sometimes it doesn't for some folks. So let me just take you through a quick alternative, because this shouldn't really be that hard. Because you're looking for really a graph of two sentences, a number that is less than 3, so x is less than 3, and a number that's greater than negative 1. So there's no reason why you can't just graph them both separately and then just find the overlap. All right? But this would be side work. So for some folks, that's too much work. They don't want to do it. So, but I would look at this and say x is less than 3. Normally I'd graph and shade that to the left. The other one is x is greater than negative 1. So normally I'd graph and shade that to the right. What I'm looking at is poor quality line. So what I'd be looking at is the overlap between the two. All right, so I'd be looking at from here to here, with this being the solution, so the overlap. All right, but only because it's and. All right, so another way to write the compound inequality would be to say that, okay, x has got to be more than negative 1, but at the same time, it has to be less than 3. All right, now we learned Thursday that there's another type of notation that we could use called interval notation. So instead of writing negative 1 less than x less than 3, I could use parentheses and then write what? Outstanding. This is a highlight of my day right now. I mean, granted, you learned it so long ago. It was almost a week. No, it was not almost a week. It was 2 school days ago. Remember parentheses, brackets? Some problems involve infinity. This one does not, because it doesn't go on forever in either direction. Where does it start? Negative 1. Where does it stop? 3. And what should I put around the 3? Parentheses or bracket? Parentheses. All right? Because bracket includes the value, parentheses exclude the value. Brackets include, I'm not sure what I just said. So brackets include the value, parentheses exclude the value. All right? So open circle goes with parentheses. Closed circle goes with brackets. Arrows, those are typically associated with infinities, and infinities always get parentheses. All right? All right, so can you think of a number that's less than negative 4 or greater than 0? So it's not going to be both at the same time. Just give me one or the other.
Negative 5.
Negative 5. Sounds wonderful. I'll even plot it. Right there. Now, what about something on the other end? Something greater than 0? 6 million, or 5. Or 1, or 0.2, or anything bigger than 0, obviously. All right. So what you would have to do in this case is graph the negative 4 with an open circle, shade to the left, graph the open circle on 0 and shade to the right, but this one's not going to have any overlap, no overlap. No overlap? No. No overlap. All right. And that's because, and it goes back to the truth tables on the previous page. You're not going to satisfy both sets of values at the same time. Now, or at least numerically. Bless you. There are some circumstances in real life where you could satisfy two different characteristics at the same time, but in the case of solving a simple equation where x equals a particular number, you're probably not going to satisfy both parts at the same time. One or the other will do. All right, so another way to write this compound inequality is actually pretty simple, because whenever you see or, you're just rewriting the inequality the way they gave it to you. All right, so x is less than -4, or, so v, x is greater than 0. All right. The one thing you're not going to do, so not, you're not going to write it as a compound in that form. All right, so you're not going to write it like this. That's not how inequalities work. All right, because what's happening here is you're actually establishing that x is, by writing it in that form, between two numbers. If it's between two numbers, how could it be more than both the -4, well, how could it be less than the -4 and greater than the 0? And aside from that, I have it here written as x is greater than -4, not less than -4. So there's a whole lot of things wrong with that, but this is what people write, right? And it's very dangerous. Now, interval notation, it's not as pretty as the previous one, but if you just go by the number line, you could see that the graph is starting at -infinity. So or -infinity to -4, parentheses all around. All right, parentheses for the -infinity because -infinity always gets parentheses, and then parentheses for the -4 because it's an open circle. And then we'll also have 0 going to infinity, also parentheses all around. The one exception here is that we have to throw in a union symbol, a U. So that U means union, and it's pretty much exactly what it sounds like. It's uniting the two sets. The two unified sets together give you the entire solution set for the problem. All right. So it's kind of weird in that regard, because it seems like just another thing to remember, but you need to develop fluency with both forms of, or both types of ways to represent your final answer. Otherwise, well, you're not meeting the standards of the curriculum, and you'll get stuff wrong, at least in the short term, but in the long term, you're going to be sitting in math classes where people will be using this notation and you're not going to know what the heck they're talking about. All right. So this is kind of like the language of math moving forward when we talk about domain and range and things like that, you know, characteristics of graphs. This type of notation is going to come into play pretty heavily. All right. So then the next problem, we're going the other way. And then, well, maybe not the other way, but they're flat out giving you the inequality, and so they want us to write it in another way. That other way should be interval notation. So what would my interval notation be for this one? Bracket -2. And 4 with parentheses. All right. So bracket or less than or equal symbols, they're going to get a closed circle on the graph. Parentheses, it's going to get an open circle. And so there's your graph. All right. So it's always between when you're dealing with a compound inequality in that form. Julianne?
How do you know when to use brackets and when to use parentheses?
Because if there's a less than or equal to symbol, so less than or equal to symbol corresponds to the closed circle, which corresponds to the bracket. All right, the less than symbol corresponds with an open circle, which corresponds with parentheses. The only exception to that would be if you're dealing with infinity. Infinity always gets parentheses and an arrow on the graph. All right. Now, number 4 is a pretty strange problem because it says x is greater than or equal to 5 or x is greater than 0. All right, so we're going to graph it. First, I'm going to graph it off on the side. Just a quick sketch. So I'll put the 0, the 5, get some arrows there. All right, so greater than or equal to 5, so closed circle on the 5. That would be going to the right. Greater than 0. That's also going to the right. That should be an open circle, but the way I graphed it, it looks like it's closed. All right, so this is the trickiest situation because you're looking at it and you're saying, okay, well, what do I write down here? What do I put on the graph? You actually only need really one number line here, or one graph on the number line, because if I were to merge these two things together, what am I really going to get? 0, infinity. Because, and that's why I did the graph on the side, because really the only thing I'm putting on that number line is the graph going from 0 to infinity. All right? That's the strange situation because you're taking two number lines, or I'm sorry, two inequalities, and you're merging them to equal 1 because there is an overlap, but if I want to satisfy one or the other, all I have to do is get a value, any value that's more than 0, and I'll have met that criteria. Now, just to kind of steal my own thunder a little bit, if the question said x is greater than or equal to 5 and x is greater than 0, all right, so x is greater than or equal to 5 and x is greater than 0. The only way that it would be a true sentence would be if I satisfied both parts at the exact same time. All right? So looking at my red and purple graph here, what inequality or interval would do that? I want to satisfy both at the exact same time. From what to what? Well, it's going to be one or the other. So not the 0 to infinity. It's going to be the 5 to infinity. Because if I take values that are going just from 5 off to infinity, then I'm going to satisfy both the red and the purple. But if I do 0 to infinity, I'm going to satisfy one or the other. All right? But if I get the values going from 5 to infinity, I'll satisfy both. All right? So therefore, we would be looking at bracket 5 to infinity. Bless you. All right, so that's probably the strangest type of question, like the number 4 that was there and the one I added on. But conceptually, if you can handle these types of questions, you're fine, because this is the strangest, and if you can handle the strangest, aka the toughest, then you're in good shape. All right, so what you're gonna do for, what do we got here? This one ends at 50. All right, for the next 8 minutes or so, is just work in your package.